In this video, we'll look at problems that pertain to all four of the quadrants. So what's important to remember is the cos diagram. Now, all of our trig ratios are positive in the first quadrant, sine in the second, tan in the third, and cos in the fourth. Now, for example 1, these type of questions normally start with two pieces of information. We've got a equation and then we have a restriction. And it also states that we have to calculate these values with the aid of a sketch. Now, first of all, we need to determine in which quadrant we need to draw our sketch. So to do that, I'm going to solve for the equation. So solving for sine A, or isolating sine of alpha. I have 13 sine of alpha, and then I'm just going to take the 12 over to the other side, equals to 12, and then divide both sides by 13. So sine alpha is equal to 12 over 13. And then we see that sine is positive. This value is positive, so that means it's either going to be in the first or the second quadrant. And then we look at the restriction. Now, this restriction is only from 90 to 180. So in here, we can see from 90 to 180, that's only in the second quadrant. So this is quite easy because now we know, okay, it's definitely the second quadrant. So drawing the sketch, we start from this the x-intercept, so the 0 intercept, and we draw it up, and then we always draw it down to the x-axis. So wherever your sketch is, if it's in the first quadrant, it looks like that, second, that, third, and fourth, like that. So drawing it, going back down, now our alpha is over here, and then we think about as working from this corner over here. Now for sine, that's opposite over hypotenuse. So opposite is over here, so that's going to be 12, and hypotenuse is the 90-degree angle across the 90-degree angle. All right, now we have to solve for this side over here, and we can just use Pythagoras since this is a 90-degree triangle, and that means x squared is equal to, now we always take the long side, so that's r squared minus y squared. So we take the long one, subtract the short one. So x is the square root of r is 13 squared minus y is 12 squared. So this is 100 square root of 169 minus 144. And here you can use your calculator to just substitute this into your calculator. So this is going to be the square root of 25, making this equal to 5. So this side is then equal to 5. And with this triangle, we can now solve for any problem. If I'm asked to find, so for A, I'm asked to find tan alpha. Tan I know as opposite over adjacent, so that's just going to be 12 over 5. And for cos alpha, and this is then going to be a negative 5, because if I go to this side on the x-axis, I have positive values. This side it's negative, so this is going to be a negative. And same for my y values. If I go up, I've got plus, and if I go down, any value here would be, for example, this would be minus 12 over here and here, and plus 12 over here and here. So cos then, being adjacent over hypotenuse, is minus 5 over 13. Then for example 2, so once again we're given our equation and our restriction. First of all, I'm going to solve for cos alpha. So cos alpha is equal to negative 3 over 5. Right, so just dividing both sides by 5, I get that. And over here I see that cos is a negative value. So wherever cos is negative in this quadrant and this quadrant. And over here our restriction says from 0 to 180. So that means from here to here, making it these two quadrants. Now both our value for negative cos and our restriction falls in the second quadrant again. So when we draw our sketch, we're going to draw it in the second quadrant. And then we place our values. So this is a 90-degree angle. we've got cos as that's equal to adjacent over hypotenuse. So my adjacent side being -3 and hypotenuse is 5. And then I can just use the calculator, or I can just use Pythagoras to solve for this side. I have my y squared is equal to r squared minus x squared. So this is going to be, or y is equal to the square root of 5 squared minus -3 squared. And that's equal to 25 minus 9. And that's equal to 16, which is equal to 4. So this is then equal to 4. And then I can solve for my other values. So I have for a, I've got sine squared alpha, tan alpha. Now this is the same. This I can rewrite as sine alpha and then all squared and tan alpha. So now I just replace my values. I've got sine alpha, which is opposite over hypotenuse. So this is going to be 4 over 5 squared. And tan is opposite over adjacent. So that is 4 over -3. And then I calculate that. So this is going to be 16 over 25, 16 over 25 times by 4 over -3. And this will then give me, so let's put this into the calculator. We'll have 16 over 25 times by 4 over -3. So this gives me -64 over 75. So -64 over 75. And then for the next value we need to calculate is b. So if I have 5 tan alpha minus 1, I replace my tan with opposite over hypotenuse. So that's opposite over adjacent. So that's 4 over -3 minus 1. And this then gives us 20. So let's put this into the calculator. We've got 5, and in brackets, got our fraction there, 4 over -3. And then minus 1. So this is -23 over 3. -23 over 3. And then finally, for example 3, if 4 tan beta plus 3 is 0 and sine beta is greater than 0, evaluate these 10, or a 10 sine beta and b cos squared beta minus 1. So first of all, we solve for 4 tan beta plus 3 equals to 0. So I take the 3 over. This is then 4 tan beta equals to minus 3, and then tan beta is equal to -3 over 4. Right. So my tan is negative. That means negative in this quadrant and this quadrant. And here we're given that sine beta is greater than 0. So where is sine positive? Sine is positive over here and here. So once again, we are in the second quadrant. So we draw our triangle there. And tan is opposite over adjacent. So that means opposite over adjacent. And now the negative value can go, so this is the same as this, which is the same as this. So you have to be careful not just to assume that the negative value goes with the negative or the 3, because 3 is actually positive here where the 4 is negative, so the negative goes over there. And then to use Pythagoras to solve for my hypotenuse, I've got r squared is equal to x squared plus y squared, and then r is equal to the square root of 3 squared plus -4 squared, and that gives us 9 plus 16, which is equal to square root of 25, which is then equal to 5. Alright, so this is then 5, and then I can find my other value. So a is equal to 10 sine beta, and that's equal to 10, and then instead of beta, I write the opposite over hypotenuse, so that's 3 over 5. And then this is just equal to, this cancels, so that becomes 1 and 2, so this is just equal to 6. And then for b, we've got cos squared beta minus 1. So replacing cos beta, or we can rewrite it first if we want to. Cos beta, that's all squared. This is just what this notation says. Minus 1 is equal to, now instead of cos beta, we've got adjacent over hypotenuse. So that's minus 4 over 5 squared minus 1. And I'm just going to put that into the calculator. So we have our fraction minus 4 over 5 squared minus 1. So that's equal to negative 9 over 25.